estimation basically we don't have any specific content mentioned in the syllabus, लेकिन ए लेवल्स फिज़िक्स में ये चीज़ इम्पॉर्टेंट है कि आपको कुछ क्वांटिटीज़ डेली लाइफ में पता होनी चाहिए कि उनकी रेंज क्या होता है। बेसिकली देखें, दिस इज़ द डिफरेंस बिटवीन मैथ्स एंड फिज़िक्स के मैथ्स में अगर कोई एक्स की वैल्यू आ जाती है, यू रियली डोंट केयर कि एक्स की वैल्यू अगर 10 पावर 3 आता है या 10 पावर -8 आता है, it doesn't make a difference. Physics में if we talk about maybe whatever mass of an apple या for example mass of some object, mass of person हम find कर रहे हैं, and that turns out to be 1.08 into 10 power -4 आ रहा है किलोग्राम, then obviously this value doesn't make sense. तो फिज़िक्स में ये थोड़ा करना है, या कोई फॉर एग्ज़ाम्पल प्रेशर एट द बॉटम ऑफ अ 10 मीटर्स का कोई पॉन्ड है और आपके पास वैल्यू कुछ इस तरह आ रही है कि लेट्स से 2 इंटू 10 पावर मे बी 8 पास्कल्स आ रहा है। नाउ दैट इज़ कम्प्लीटली रॉन्ग। वैल्यूज़ का कुछ आपको अंदाज़ा होना चाहिए कि आपका आंसर किस रेंज में आना चाहिए, नॉट ऑब्वियसली फॉर एवरी वैल्यू, बट कहीं पर आपको ये ज़रूरत पड़ सकती है इवन आउटसाइड द स्कोप ऑफ पेपर, कि आपको कोई वैल्यू बता रहा है तो आपको उस वैल्यू का सेंस बनना चाहिए। फॉर दैट यू नीड टू नो फ्यू एस्टिमेटेड वैल्यूज़ आपको याद होने चाहिए एग्जैक्टली। So based on what they have frequently been asking, I'm not saying these are the only estimated values which will be asked, but they kind of cover most of the time जो इन्होंने पूछा है, तो वो इसी इसी क्वांटिटीज़ के बारे में इन्होंने पूछा है, ठीक है। सो बेस्ड ऑन प्रीवियस पास्ट पेपर क्वेश्चंस कुछ masses के वैल्यूज़ हैं, कुछ रेडियाई वगैरह हैं, वो सारे आपको आने चाहिए। masses का अगर हम स्मॉलेस्ट से स्टार्ट करें तो एक हाइड्रोजन एटम या एनी वन यूनिट इज़ 10 पावर -27 किलोग्राम। रेन ड्रॉप 0.03 grams, coin 2 grams, meter rule apple they have been frequently asked, it's around 150 grams. Obviously values are not fixed, इसी range में आते हैं, so whenever you get an MCQ and there are four options, so उसमें range में काफ़ी difference होता है, so you don't have to worry कि what if 150 की बजाय and there's an apple, और वो जो है नहीं वो तो 200 आ रहा था actually या whatever. पॉइंट ये है कि रेंज ऑलमोस्ट ये होते हैं, ठीक है। So anyway, adult person has been frequently asked 70 kilograms, family car 1500, a lorry 4000 kilogram. ये तो कुछ कॉमन masses हैं जो आपको याद होने चाहिए। इसके अलावा भी आ सकते हैं। I think there was once asked about a horse and whatever, तो इस तरह की quantities आ सकते हैं। लेकिन you get the idea. If adult person is 70 kilogram, इससे बड़ा एनिमल होगा, लेट्स से हॉर्स की अगर हम बात करें तो क्या मे बी 8 टाइम्स हैवी होगा या 700 होगा, नॉट श्योर, बट डिपेंडिंग ऑन व्हाट वैल्यूज डू वी हैव. सो दिस इज़ हाउ इट इज़ गोइंग टू बी। माइट बी कि वो कोई और, अब 2 ग्राम्स का कोई कॉइन है और वो आपसे कहें क्या स्टैक ऑफ कॉइन एटसेट्रा, वो पूछ सकता है, तो यू गेट द आइडिया। रेडियस की अगर हम बात करें, एटम का रेडियस 10 पावर -10 मीटर्स है, ऑलमोस्ट नैनोमीटर्स में होते हैं। गोल्फ बॉल 2.37 सेंटीमीटर्स, टेनिस बॉल हैज़ बीन फ्रीक्वेंटली आस्क्ड 3.5, फुटबॉल 10 सेंटीमीटर। अच्छा रिमेंबर यहाँ पे एक बाज़ ऑफ वॉल्यूम का भी पूछ लेते हैं, तो स्फेयर का वॉल्यूम आना चाहिए which is 4 by 3 pi r cube. So sometimes they do ask about volume, etc. Earth का radius is 6400 kilometers on average. Density is very very important. Water की density याद होनी चाहिए. If you're talking in gram per centimeter cube, it's 1. तो volume water का अगर let's say 500 cm cube है, it means कि since the density is 1 gram, तो इसका mass भी 500 grams होता है. So this is a relation that you have to keep in mind as well. So the same water has a density of 1000 if we talk about kilogram per meter cube. स्टील या जो ट्रांजिशन एलिमेंट्स जितने आपके पास या एलॉयज़ जो हैवी यूज़ होते हैं, दे आर अराउंड 8 9 ग्राम पर सेंटीमीटर क्यूब और 8000 किलोग्राम पर मीटर क्यूब. Density में I would like to add mercury as well. Mercury is the densest liquid, which is 13.6 gram per centimeter cube. तो ये मरकरी की डेंसिटी है. स्पीड साउंड स्पीड ऑफ साउंड इन एयर 330. लाइट का if I'm not wrong, it's given on the first page of your paper as well, 3 into 10 power 8. Olympic runner has been, I think, asked every 2 years or 3. They ask Olympic runner का ये ज़रूर पूछते हैं, so you should know कि it's 10 meters per second. And these values seem to be very they seem to not make sense, but usually in class whenever I ask, I get like a huge range of values. When I ask on average unki kya speed hogi, and some students are like 50 kilometer per hour and they absolutely have no idea. So during those questions, class discussion, I realized the importance of estimation. Okay, you should have uh, these values in your mind when you look around. थोड़ा सा कुछ आइडिया आपको होना चाहिए कि ऑन एवरेज masses क्या होते हैं, etc etc. So anyway, Olympic runner is frequently asked. I would say this is very important. इसके अलावा time taken कुछ आने चाहिए. Life span of a person 70 years. Secondly, अगर वो seconds में पूछे तो 1 year is 365 days, 24 hours, 3600. तो 1 year को आप इस तरह कन्वर्ट कर सकते हैं. Light to reach time taken for the light to reach sun from sun to earth, it's 8 minutes. On average it's 8 point something आता है. Frequencies ये हम waves के chapter में discuss करेंगे in detail. So you need to have these, you need to memorize all of this. I would suggest कि अगर आप wavelength या इसमें से एक याद कर लें, या तो आप frequencies सारे याद कर लें या wavelengths सारे याद कर लें. Because you can always convert wavelength into frequency by the formula, which is V is equal to F lambda. Sorry, let me just wavelengths के अगर values हैं आपके पास ये सारे, and if you memorize, let's say wavelengths आपको याद, आपने याद कर लिए, you practice and you memorize wavelengths, then you can always find frequency, which is V by lambda. V for speed of light is 3 into 10 power 8. So whichever wavelength you put, you will get the frequency. ठीक है. If you put the smaller wavelength, you get the larger frequency. Yeah, larger because they are inversely proportional. So this value is connected to this, and this value is connected to this. So anyway, I would suggest memorize one of the table and use formula if they need frequency. Um, कुछ कलर्स के आई डोंट थिंक कि यू नीड टू मेमोराइज ईच एंड एवरी कलर. एक्सट्रीम वैल्यूज़ तो याद होने चाहिए. ब्लू और वॉयलेट का रेंज पता होना चाहिए. रेड के वेवलेंथ्स याद होने चाहिए. दिस इज़ वेरी इंपॉर्टेंट. तो दीज आर सम ऑफ द इम्पॉर्टेंट क्वांटिटीज़ दैट यू हैव टू कीप इन माइंड. इसके अलावा रेजिस्टिविटी आपको पता होना चाहिए. इलेक्ट्रिसिटी के MCQs में आ सकता है. 4 वैल्यूज़ गिवन होते हैं, यू नीड टू मेमोराइज. स्पेशली जो फैक्टर है ये याद होना चाहिए. Number density we'll discuss in detail. What is number density? That's 10 power 28. इसका भी ये फैक्टर. नंबर डेंसिटी वैसे बेसिकली हमें बताता है कि हाउ many electrons exist per unit volume. Let's say 1 मीटर का cube है of a metal, and if you count number of electrons available for conduction, that is called number density, and we'll discuss this in detail in electricity chapter. इसके अलावा यंग मॉडुलस हैज़ बीन फ्रीक्वेंटली आस्क्ड. 10 पावर 11 या 200 गीगा पास्कल्स मल्टीपल टाइम्स आया हुआ है. तो स्टील कॉपर के ये वैल्यूज़ याद होने चाहिए. एटमॉस्फेरिक प्रेशर 10 पावर 5, वेरी इंपॉर्टेंट अगेन. तो ये तो चैप्टर वाइज भी कुछ क्वांटिटीज़ आएंगे जो आपको याद होने चाहिए. I'm not saying that this will cover everything, but I would say most of the values जो हैं वो यहाँ से cover हो जाएंगे. What we'll do is we'll solve few past paper questions ताकि ideas हमें और clear हो जाएं. इसके अलावा भी आ सकता है, बट आई थिंक अगर आप ये मेमोराइज़ कर लें और बाकी जो है इससे अंदाज़ा लगाएँ, दैट वुड बी बेटर. So anyway, we'll start with the worksheet in a while. What could not be a measurement of a physical quantity? So for physical quantity, we need to have a proper unit. So 10 Kelvin, well, this can be a physical quantity. 11 joule per Newton per meter. 11 joule. This is what, but the problem is joule itself is Newton meter. So 11 Newton meter divided by, so the unit cancels out, which means it doesn't have a unit, it can't be a physical quantity, so B is the answer. Other units won't cancel out, like terameter is unit of length, Newton per meter cube, if we simplify, still some units are left. So it can be a physical quantity, but if there's a value without a unit in none, then it's not a physical quantity. So 1 is B. What is MCQ2 is what's a reasonable estimate for the density of sand? So the first option is 200 grams per centimeter cube. As I mentioned in the slides, water has a density of 1 gram per centimeter cube. Now, if you have a beaker of water and a beaker of sand, I can't say that sand has to be 200 times heavier is impossible. 2000 times heavier is impossible as well. These are just way too heavy. So for instance, this is 50 grams. This cannot be 200 times or 2000 times heavier. So I'm not going for A or B. It might be what, 100 twice or thrice at most. So I'll not go for A or B. C is 20 kilogram per meter cube. So in kilogram per meter cube, water has a density of 1000. According to C, they are saying that sand is less dense than water, so C is incorrect as well. Then we have only one option left, which is 2000. So it makes sense, if water has a density of 1000 kilogram per meter cube, then sand must be 2000 kilogram per meter cube, which is totally acceptable. MCQ3 is what's a reasonable estimate of volume of an adult person? Okay, so adult person, there are different ways to solve it. We can have approximate lengths and then use the formula of volume. Treat a person as a cylinder, maybe. There are different ways to go about it. I would suggest, if we again go for the water, well, if you see if you can swim around, आपको ये आइडिया है कि हमारी डेंसिटी ऑलमोस्ट वाटर के लगभग है. See, our body is mostly water, and we can, based on the amount of volume of air that we have in lungs, we can float on water, on the surface of water, or we can dive into the water. So मतलब हमारी डेंसिटी ऑलमोस्ट 1000 के करीब ही लगभग होगी. So if I find density in each case, I know adult person I mentioned has a mass of 70. So if I find density according to A, so 70 divided by volume, which is, so this is 700 kilogram per meter cube. Let me look at other options. 70 divided by volume 0.5, so this is 140 kilogram per meter cube. This is 70, and this one is 35. So you see, these densities are way too less compared to the density of water. 700 kilogram per meter cube makes absolute sense if, based on the volume and mass of an adult person, the density has to be near to that of water. So remember, the water has a density of 1000 kilogram per meter cube. You can have a brief idea on other densities. So we'll go for A. MCQ4, what is not a reasonable estimate of physical property indicated? Option A is 2 into 10 power 3, 2 kilowatt for the power dissipated by heating element of electric kettle. Well, remember, all of these electric heaters, kettle, they are from 1 kilowatt to 2 or 3 kilowatts. So This is, it makes an absolute sense. We'll go for that. 400 for the volume of water in a swimming pool. So if you just imagine 1 meter cube is when you have like these meter rule arranged in such a manner. So yes, this is 1 meter cube, and if we have 400 of them, this can be true. I mean, it's not a very absurd or a very a value that is way too off. Seems to be fine. 5 into 10 power 5 Newton second for the momentum of a lorry. Momentum of a lorry. We'll look into this option. We'll see if D makes sense or not. Uh, 6 into 10 power 2 for the weight of a fully grown racehorse. 600 Newton means it's around 60 kilograms, which is less than mass of an adult person. This is an absolutely incorrect estimation, and or it's not a reasonable estimate at all. We'll go for option D. It has to be at least greater than the average mass of an adult person, obviously. MCQ 5. What is a reasonable estimate of kinetic energy of an Olympic athlete sprinting in a 100-meter race? Um, as I mentioned, we have a formula of kinetic energy as half mv square, and I mentioned mass of an adult person 70, Olympic runner is around 10. So if we look at this value, if I calculate half into 70, so it's 3500, which is which can be rounded off to 4000 joules actually. So this is 3500 joules. Anyway, we'll move forward. MCQ 6. What is essential when recording a measurement of a physical quantity? It should have an SI unit. The measurement has a unit and a number. This is true as well. The measurement has a unit given and a base. Well, base is not that much important. The measurement is from analogous scale. It's not important. It can be digital scales. So more importantly, it's not just made up of a unit. It should have a unit and a number. I'll go for option B. MCQ 7, which row shows what all physical quantity must have? It should have a magnitude, obviously, so D is incorrect. It should have definitely a unit, so then we have only direction may or may not be, it's not a must actually, so I'll go for option C. If you have a direction, fine, it's vector. If you don't, it's a scalar. So it's not a must have, it's just an option. We'll go for MCQ 8. A paperback book contains 210 sheets of paper. Thickness is measured with a ruler as shown. So they want a thickness of 1 sheet, so we'll divide by 210, whatever the value is. So this is, and the answers are all in millimeters, so I'll go for this as 9 mm, which is 0.9 being shown over here, and this is 36 mm. So the difference is 25 mm, right? So 36, let me just confirm, 36 minus 9, sorry, it's 27 mm. And if we divide the 27 by 210, 27 divided by 210, so this is 0.128, so the answer is C. Okay, so for the MCQ 9, the table shows some measurable quantities. Which row gives the correct order of magnitude of the measurable quantity in the stated unit? So if you look at these options, mass of a coin is 10 power minus 4 kilogram. 10 power minus 4 actually refers to 0.1 gram, which is way too small, so we'll reject A. Thickness of a sheet of paper, 10 power minus 2 meters. 10 power minus 2 actually refers to 1 centimeter. That's just way too big. We just saw this is 0.13. Weight of an apple is 10 power 0, which is 1 Newton. This is fine. Temperature of a person body 10 power 1 Kelvin. This is just way too little. This is actually minus 263 degrees Celsius, which is a completely wrong estimate. So we'll go for C. What's the reasonable estimate of kinetic energy of a car traveling at a speed of 30 meters per second? I'll go for the formula I mentioned in the slide. Average mass is 1500, 30 square. So if you calculate this value, half into 1500 into 30 square. So this is 6.75 into 10 power 5 joule. So the if you round it off to the nearest 10, then this is 10 power 6 joules. MCQ 11, what's a reasonable estimate of mass of a raindrop? So it's not obviously 10 kilograms, it can't be 100 grams. This is 100 grams. It's not even 1 gram, because if you look at burette, uh, 1 centimeter cube has actually 10 drops on average. So we are talking about way smaller than 1 gram. So we'll go for option D. MCQ 12, a man is running a race in a straight line. What's the approximate kinetic energy? We saw earlier over here it's around 3500 or 4000 joule, but that's an Olympic athlete. If we are talking about an average person, then it would be less obviously. So 1000 joule would do. Which quantity is a physical quantity? Atomic number is actually a ratio. Efficiency is a ratio as well. Number density is number of electrons per meter cube. It has a unit, so we'll go for C. Strain is a ratio as well, so we'll go for option C. 14 is a student uses the volume of metal coin in order to determine the density of the metal. What is not needed in order to find volume? Well, if you want to find volume, you do need a diameter, you need thickness, you need formula. You don't need mass to find volume. You need mass only if you want to find density. MCQ 15, November 20, it was asked, what's a reasonable estimate of volume of fully inflated standard football? Well, that has a radius of 10 cm cube. We can use 4 by 3 into pi r cube, 10 cube. So we have this formula. We can use 4 into pi into 10 cube. So this is around 4000. I would go for B, which is 6000 cm cube. MCQ 16, for which quantity is the magnitude a reasonable estimate? Frequency of a radio wave, we'll come to this in a while. Mass of an atom, it's not 500 into 10 power minus 6. This is completely wrong. Young modulus of a metal, 500 kilopascals. Well, this is wrong again. It has to be in gigapascals. So C is wrong. Then we have wavelength of a green light, which is 500 nanometers. So if we look at the wavelengths, they range from 700 to 500 nanometers. So for 700 to 500, 700 is of blue and this is of red, so it is in the range. This can be the correct answer and A will be incorrect. If we look at if you go back to the slides and look at the frequencies, radio wave has a frequency, it has a very high frequency. It's not in picohertz, it is around 10 power 11 hertz. So this A is incorrect. So we are only left with one option, which is D. So for MCQ 17, a cyclist has a speed of 5 meter per second and a small car has a speed of 12. Which statement does not give a reasonable estimate? The kinetic energy of the cyclist is 1 into 10 power 3. So we can use half into mv square, 70 into 5 square. We'll see what value do we get. Half into 70 into 875, it is around 1000 joules. We'll keep this for a while. Kinetic energy of the car is 7 in 10 power 4. So half into 1500 into 12 square, half into 1500 into 12 square is 18,000 joules, which is 2 into 10 power 4. Well, it is slightly more, but we'll keep it for a while. The momentum of the cyclist is 4 into 10 power 2 kilogram meter per second. So momentum is m into v. So if we have mass of 70 into 5, which is 350, 400, so this seems to be correct as well. The momentum of the car is 2 into 10 power 5. So mass is 1500 and velocity is 12. So 1500 into 12 is 18,000, which at most is 10 power 4. So this is not a reasonable estimate. Other are somewhere still close, but this one is just way too off. So we'll go for option D. MCQ 18, which quantity with its unit is correct? Acceleration is meter per second square. That's wrong. Electric current is just ampere, not ampere per second. Incorrect again. Electric potential difference, joule per coulomb. Yes, that does refer to volts. So C is correct. Kinetic energy is 4500 Newton per meter. Well, it's Newton meter if you want to write in joule. So 18 is incorrect. MCQ 19, a sheet of gold leaf has a thickness of 0.125 micrometer, which in actual is 0.125 in 10 power minus 6. A gold atom has a radius of 174 picometer, which is 174 into 10 power minus 12. Approximately how many layers of atom are there in the sheet? So we have the total thickness of the sheet, which is 0.125 in 10 power minus 6, and each atom occupies, actually, if this is the radius, then it actually occupies 2 into 174 into 10 power minus 12 distance. And now they're asking how many atoms will be there. So we just have to divide 0.125 in 10 power minus 6 by a length of each atom, or the diameter of each atom, which is 2 into 174 into 10 power minus 12. So if we divide 0.125, so this turns out to be 360, which is 400. MCQ 20, what is the best way of describing a physical quantity? A quantity with magnitude. Direction is not important. Magnitude and a unit seems to be correct. Magnitude but no direction. Well, there are quantities with direction. No magnitude is impossible. So the answer will be B. MCQ 21, the radius of the earth is approximately 6.4 in 10 power 6 meters, and the radius of moon is approximately 1.7 10 power 6. A student wishes to build a scale model of solar system using a football of radius 0.12 meters to represent the earth. Which object would best represent the moon? So first we have to see the actual ratio just to get an idea. So 6.4 in 10 power 6 divided by 1.7 10 power 6. This is 3.76 times earth is bigger. So if this is represented by earth, then we have to divide by, if we divide 0.12 by 3.76, so this is actually 0.032 meters. So we are talking about 3.2 centimeters. So basketball would definitely be incorrect. That's larger. Cherry is just way too small. Golf ball must be small. This might be what, 1 centimeter. This might be 2 centimeter. Tennis ball is fairly 3 to 3.5 centimeters. So we'll go for option D. Anyway, MCQ 22. A car is traveling at a speed of 20 meters per second. The table contains values for kinetic energy and momentum. So as I mentioned earlier, mass is taken as 1500. So if you want to find kinetic energy, half into 1500 is mass of car into 20 square. So this turns out to be 1.1500 into 400 divided by, this is 300,000, which is 3 in 10 power 5. So A and B seem to be correct. If you talk about momentum, so 1500 into 20, which is 30,000, 3 in 10 power 4, we'll go for option A. Which statement is not a reasonable estimate? Atmospheric pressure at 10 power 5, this is a reasonable estimate. Light takes 500 seconds, so 500 divided by 60 is around 8.3 minutes. This is true as well. The frequency of ultraviolet is 3 in 10 power 12. I'll go for the other option first, then we'll come to C. Lifespan of a man is 2 into 10 power 9. 2 into 10 power 9, which is in terms of years 365. 2 into 10 power 9, 63 years. Yeah, so D seems, C must be incorrect. The frequency of ultraviolet is 3 in 10 power 12. So ultraviolet is around 400 nanometers. So if you want to find frequency, so 3 into 10 power 8 divided by 400 into 10 power 9 minus 9, this is the frequency of ultraviolet, which means the value must be around 10 power 18 or something, 17 hertz, or 10 power 15 hertz if we just calculate it. So this is smaller, so C is incorrect. MCQ 24. A student creates a table to show reasonable estimate of some physical quantities. Which row is not a reasonable estimate? Mass current might be 12 ampere, fine. Mass of adult, fine. Speed of Olympic sprint runner, fine. Water pressure at the bottom of a garden pond, it is around 10 power 5 pascals. It's not 1000 times, 10 times more than the atmospheric pressure. D is incorrect. 10 power 5 it should be. What is average speed? I mentioned earlier, female Olympic runner must be 9 or 10. What is the best estimate of kinetic energy of a family car traveling at 50 kilometers per hour? So remember, one point that we have to keep in mind is 50 has to be converted into meter per second. So multiply by 1000 divided by 3600, then take a square. So we will have to 50 into 1000 divided by 13.8. So we get the answer around 48. 4.8 into 10 power 4. 10 power 4, which means the nearest that we can get is option B. So this is pretty much it about estimates. We'll start with new chapter in the next lesson.